All right, this video is going to go over pages 22 through 25 in your waves packet. So we're going to talk about interference. So wave interference occurs when basically two waves meet along the same medium. So once they run into each other, something's got to happen. Okay, so we have a term called the principle of superposition. Okay, so I'm going to read the definition, then I'll basically explain it to you more simply. Okay, so when two waves interfere, the resulting displacement of the medium at any location is the sum of the displacements of the individual waves at the same location. All that means is if you have one wave meeting another wave, once they meet, you're basically going to add up their amplitudes to each other, which can either make the wave bigger or smaller depending on which way the amplitude's facing, which we'll talk about here in just a second. So your first one we're going to talk about is constructive interference. So what happens is, let's say we have wave A is heading this way. So wave A is going this way. And we have wave B heading towards wave A. Okay, so both individual waves at this point, okay, if we notice they're both crests, so this would be a positive amplitude for both of them. So basically what happens whenever they meet up in the middle is if they're both positive or both crests, what they're going to do is they're going to make each other bigger. They're going to combine to make one crest. So now it's A plus B. Okay, so this would be your before. This would be your after. Oh, I'm sorry. This would be your during. And then after, once they've met up in the middle, what they're going to do is they're going to just go right back to the way they were. So now B is over here. It's gone back to its normal amplitude, and B is still heading to the left. And then A is going to be over here, and it's back to its normal amplitude, and now it's heading to the right. Okay, so this would be constructive interference. So constructive means to build up. Okay, so that means that it's going to make the amplitude even bigger once they combine. Now, it doesn't always have to be a crest. Okay, so let's say you had wave A is a trough. Okay, and then you have wave B is a trough. Okay, wave A is heading towards wave B, and wave B is heading towards wave A. Once they meet in the middle, okay, they're both negative or both troughs, so it's going to make an even bigger trough. Okay, so A plus B. Okay, and then they would go back to the way they were, so B would go back to its normal size and keep going, and A would go back to its normal size and keep going. So this is more importantly just to show you that just because it's a trough, okay, it can still be constructive. Everybody associates a trough with being negative, and so they think there's no way that can be constructive if it's negative. Well, if you have a negative and a negative making it even more negative, that would be considered constructive. Okay, so now let's talk about the opposite. Let's talk about destructive. So destructive occurs basically when you have two interfering waves that have a displacement in the opposite direction. So let's talk about our before. So our before is we're going to have wave A right here. Okay, and wave A is going towards the right. And we're going to say wave B is right here. And that's negative because it's trough. So we have a crest and a trough. And they're going towards each other. So what's going to happen when they reach each other? So this would be a positive, and this would be a negative. Now, for the sake of this one, we're going to say they both have the same amplitude. So let's say this is a positive 5, and they'll say this is a negative 5. So once they meet in the middle, what's going to happen? So during, when they meet, a positive 5 and a negative 5, if you add those together, they're going to cancel out to 0. So this is basically what the wave would look like, is there's still technically a wave going on, and it's still A plus B, but they've canceled each other out once they meet in the middle. And once they cancel each other out, okay, they've done their thing, they'll keep moving on. So now B goes back to being a trough, and it still continues to go towards the left. Okay, it's still negative. And then A goes back to being a crest. Okay, it's still positive, and it's going towards the right. Okay, so in that case, they just canceled out. Now, they don't always have to have equal amplitudes, so they do not need to have equal amplitudes. So let's take a look at an example. Before is, what if I had a trough with a negative 4, okay, meets up with a crest of a positive 6. So let's say this negative 4 is going towards the right, and the positive 6 is going towards the left. So what's going to happen when they meet up? You add those together. Just be careful with your math. It's actually more easier than you think to mess this up. So negative 4 plus 6 is going to give you a positive 2. So when they meet in the middle, what's going to happen is you're going to have a smaller amplitude in the middle. It's still going to be positive, and it's only a positive 2. So this is during. And then after, they're going to go back to the way they were. So this goes back to being a positive 6, going to the left. Okay, and then this goes back to a -4 going to the right. Okay, so another example would be, let's say I have a +3, okay, going to the right, and let's say I have a -7 going to the left. Okay, so +3 plus -7, okay, or 3 minus 7 is going to give you a -4. So basically what I want is I want a little bit smaller amplitude than that 7, so that's going to be a -4 when they meet in the middle. And then it goes back to -7 over here, going to the left, and then +3 going to the right. Okay, so that would be destructive interference. Now, when you have things like sound and stuff, like there can be constructive and destructive things going on at the same time. So like when you hear a bunch of people talking in a room, okay, that would be examples of both constructive and destructive, okay, because you have all sorts of sound waves. They're all being jumbled together. So at some points your crests are going to line up, some points they're going to not line up. Okay, so that's going to create a whole bunch of construction and deconstruction there. So typical sounds are going to be more jumbled. Okay, so you've got constructive and destructive all over the place, so it doesn't always look so pretty. Okay, but when we actually do have something line up, okay, which we're going to talk about in the next video, is called a standing wave, is when you have two waves that actually match up. Okay, so they actually have the same amplitude, same frequency, same wavelength. Okay, they're just going in opposite directions. Okay, that's going to make a standing wave, which what we call pitch. Okay, so it's going to actually be a more harmonious sound than basically noise, which would just be a bunch of random waves all mixed together. So let's say I have a wave doing this. Okay, so it's traveling along. Okay, so this is your transverse wave. Okay, now a standing wave is basically going to be whenever you have the same wave just going the opposite way, and they time up perfectly with the same amplitude, same frequency, same wavelength. Okay, so what it's going to do is it's going to create this nice harmonious wave where that's where we get things like pitch, okay, or that nice clean sound. Okay, so a couple of terms that we're going to talk about is a node and an anti-node. So a node, so the way I remember this is node means no. Okay, so node means no amplitude. This would be when there's destructive interference going on. So when would you have zero amplitude? Well, if this is your origin line and the origin line is a 0, well, when do we have 0? Okay, let me switch up colors a little bit. We have 0 here, 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 and here. Okay, so if I asked you how many nodes are on this, this would be 5 nodes. Okay, and now antinodes are just the opposite. Antinodes are when you have maximum displacement, or when do you have an actual peak like this? You actually have maximum amplitude. Okay, now you don't need to count both sides. Okay, so all you gotta do is pick top or bottom, because it's still, once it's a standing wave, it still basically sounds like one wave. So we don't need to double count. So I have 1, 2, 3, 4 antinodes. Okay, so antinode is something where it has amplitude, and a node is where it does not. It has 0 amplitude. Okay, going on to true false. So 1, when two pulses meet up with each other while moving through the same medium, they have a tendency to bounce off each other and return back to their origin. Well, the constructive and destructive, it can be constructive and destructive for that time where they meet, but they don't bounce off each other. They basically just go through each other, combine for a brief moment, and then they just keep on going. So this would be false. They go through each other. 2, constructive interference occurs when a crest meets up with another crest at a given location along the medium. That would be true. Okay, destructive interference occurs when a pulse with an amplitude of +5 units interferes with a pulse of -5 units. So if a +5, -5, they're not going to make each other even bigger. They're actually going to try to cancel each other out. Okay, so this is going to be true, destructive interference. Number 4, destructive interference occurs when a trough meets another trough at a given location along the medium. This would be false. This would be constructive interference. So again, be careful of that. Just because you assume a trough is negative, if you have a trough meeting another trough, they're just going to make an even bigger trough, which is constructive. Number 5, if a pulse with an amplitude of +5 units interferes with a pulse with an amplitude of +3 units, the resulting amplitude will be a medium of 4 units, the average of the two individual amplitudes. Well, if you have a positive and positive, all you got to basically do is just add them up. So +5 plus +3 is going to give you a +8. There's no mention of doing averages, so don't think that's correct at all. So Do not do anything average. All you gotta do is add them. So +5 and +3, that is gonna be a +8. So this +4 is wrong. So this is gonna be false. Number 6, if a pulse with an amplitude of +5 units interferes with a pulse with an amplitude of -3 units, then neither constructive or destructive interference occurs. Well, if I was asking what type of interference would this would definitely be destructive because you have a positive and a negative. Okay, so there's definitely interference going on. So when two waves meet each other, there's always some type of interference. It's either constructive or destructive. Okay, so you can't just say there's no interference at all. Okay, so this would be false. Number 7, two sound waves could never interfere in such a manner to cancel each other out, okay, and produce silence. Okay, so this would be false. Okay, so that's how noise canceling headphones work, is it basically interferes perfectly with the sound coming in to where basically those amplitudes will cancel each other out where you don't hear that loudness, and that makes things a lot quieter. Okay, so that's how those actually work. And we'll talk more about sound and more standing waves in the next video.